Hi, and welcome to Data in Depth, a podcast where we delve into advanced analytics, business intelligence, and machine learning, and how they're revolutionizing the manufacturing sector. Each episode, we share new ideas and best practices to help you put your business data to work. From the shop floor to the back office, from optimizing supply chains to customer experience, the factory of the future runs on data.
Welcome, and thanks for joining us for Season 2 of Data in Depth, the podcast exploring data and its role in the manufacturing industry. I'm your host, Andrew Reiser. Today we are joined by Ed Kuzemchak. Ed is the Chief Technology Officer and Director of IoT and Embedded Systems Engineering at Software Design Solutions, which is an Applied Visions company. Welcome, Ed.
Thank you, Andrew, for having me on.
Yeah, super excited about today's topic and digging a little bit deeper into it. But before we get into the meat of things, it would be great to hear a little bit more about your background and what led you to IoT in this world of embedded systems and what led you to Software Design Solutions.
Sure. I have about 30 years experience in embedded systems, and the first almost 15 of those was actually at other companies. I was part of a defense contractor, Raytheon, and then part of a small startup doing embedded systems. Then that small startup got purchased by Texas Instruments. And so throughout that, the common core of all those things had to do with helping people build embedded system software, very tight code, very power efficient or memory efficient code. And then as we started Software Design Solutions 16 years ago, we focused on that particular software, embedded software, firmware kind of market. And back then there was no IoT. IoT wasn't even a word. It was formed, but certainly the same concept still existed. Back then it was called machine-to-machine communications. And, I still kind of like to bring that up to folks that, IoT didn't spring out of thin air. It was an evolution of machines talking to machines, but now the internet has enabled more things to talk to each other. And so as Software Design Solutions got involved more and more in more embedded systems talking to other embedded systems or embedded systems talking to computer control systems, we got very involved in the machine-to-machine communication and then finally into what sprang up as IoT.
Yeah, I think that's a good point to point out that a lot of technology, I think when you think back on it, has been around for a while, and just these evolutions of things like the internet and different programming language and different ways of which systems communicate certainly evolves, but the concepts still hold true to things that have previously been completed in prior evolutions. So obviously the internet was a big tipping point to now allow traditionally kind of dumb devices, if you will, to become smart devices or turned on and able to share data between one another. So we'll tackle a little bit of that here in a second, but I think maybe we can keep pulling on that string with just IoT. So now we fast forward, machine-to-machine communication is in play. This new buzzword of Internet of Things has now become prevalent. So what's your point of view on that? And maybe more specifically, how does a company frame or draw a box around Internet of Things and wrap their head around it so that they can make something tangible?
I think the most important part for a company to do is to look at their systems that they have today and say, what part of these systems that we have today can we make more efficient or more cost effective or higher performing if we had better information? Because that's really all that IoT is about. It's about gaining data where you didn't used to have data, or you couldn't get as good of data or as up to date of data. If you had to wait until the reports came back from the field, from your field sales tech or your field service techs on machine failures, you might have a 2-week lag on machine failures, and your data that you're looking at is always 2 weeks old. Well, what if it was only 5 seconds old? Would that improve your system? If it wouldn't, then ignore that for the moment. Maybe that's not worth looking at for you. But if it would, that's important. Or if you even better could reduce the number of truck rolls that your techs have to even go out and do to gather that data. Maybe they don't have to go visit that piece of machinery out on a pipeline in the middle of nowhere in the woods somewhere, unless that machinery is not behaving the way it should. And I think that's the box that, as you say, that the companies need to draw around IoT. Sometimes folks come to us and a C-level has pounded their fist on the table and said, we got to get a hold of this IoT thing. We've got to get IoT in our system. And so the C-1 levels come to folks like us and say, well, what can IoT do for us? And, our question back immediately has to be, well, what do you have? What do you want to make more efficient? Because that's what you need to address.
I think that makes perfect sense. I was listening to a webinar earlier today around the state of manufacturing. And most manufacturers that we talk to, I think the constant theme is also trying to do more with less. And so I think with COVID-19, we're seeing this really come to light as well. So trying to identify areas of opportunity where technology and things like IoT and sensors can reduce the manpower footprint, but also provide scalability as it relates to leveraging some of these technologies. To your point, an example that you gave, avoid potentially having to send somebody out into the field to check on something, whereas the data could be streamed from the sensors back into the manufacturer's home base and provide that real-time update.
Yes, because it used to be that reducing those kind of truck rolls was all about the dollars and cents of the truck and the gas and the person driving. But now it's also a hazard that you have to consider.
Yep.
It's a way that you can make your employees, your most valuable resource, safer. And that's going to, as you say, kind of change the calculus of some of these return on investment decisions that are made. It might not have to do any more with, well, is it saving us enough in gas? And well, that guy has to go there anyways. And what if he doesn't? What if he doesn't have to go there? What if it can be done remotely? What if it can be done with the staff that's there? It doesn't need our technician. Let's keep the folks separated and just have them initiate the sensing to do the data read.
Right. So I think a lot of times when you think about these projects and the evolution of them, there's typically, at least in some studies, a high propensity for failure or deeming the project as being a failure or not meeting the expectations of what it was set out to do. So when we were speaking earlier, I think you had shared really this concept around an agile mindset. And so maybe you can expand upon that a little bit more and how that applies to these types of projects.
Sure. I think that the very first thing to say that is a little controversial is don't be afraid for it to fail. Mm-hmm. And you do that in every business. You do small things quickly and expect some of them to fail and some of them to win and some of them to win big. You play small, many bets. And I think that the important thing there is to not consider IoT as this big multi-year 6-7-figure project that we have to understand all of it and then cost out and do the ROI on all of it and then get all of it approved and then go do all of it. That is the most unagile way to behave. The more important way to do this, or the more efficient way to do this, is to let's go look at some short wins, some low-hanging fruit that can be addressed, and let's go look at the most important pain points that you have, or perhaps not that it's the easiest ones to address. And let's go try that out, and expect some of them to fail, and hopefully they'll fail fast. We might be able to go out and with off-the-shelf hardware and off-the-shelf sensors and something like our asset management system to collect the data, we could, in a very short time frame, say, you know what, that data is not very helpful to you. Let's go do this other data instead. And what you've done is you've gathered a piece of information that you didn't have to spend a lot of money to learn. And you pivot and you say, now this data was important to gather. Let's go do the next step on that and go down the next step and say, okay, now we're not going to do off-the-shelf hardware. We're not going to do off-the-shelf sensors. We're going to do something a little more exotic, something a little more cost-effective potentially that we can produce tens or thousands of, and we can get them out in the field and we can have battery lives instead of 2 months on a prototype, maybe we can have 2 years on a battery.
Yeah, I think the agile mindset is definitely a key element of this. Not only just to your point, identify what's working and what's not working and be able to iterate off of that, but I think it also helps lower the bar to where you feel like you aren't boiling the ocean and trying to tackle too much, but it makes these projects a little bit more bite-sized.
Yeah, I think that's the key. Folks tend to lump, if they're not doing IoT yet, they tend to lump IoT into an R&D department, and it really has a hard time there. because what you really need to do is do some quick small projects. It's almost better if it stays out of the R&D budget, because R&D is usually a 2 to 3 year kind of time frame, and that's not what we want here. We want a 2-month time frame. We want to get data back in 2 months and figure out whether that data is even worth collecting, and that process needed to be reasonably inexpensive to do.
Yep. So in projects like this, talent becomes a key element. So you've got the business value, the ROI that you're looking to accomplish, but then you also have the stakeholders and the talent of executing this project. Maybe you can expand a little bit on that and kind of what you see works and doesn't work as roles within a company.
Sure. I mean, I think that one of the most important things to do is, as you say, is to identify the stakeholders. And that's not just the people writing the checks or the people who are going to identify the plus minus on the ROI, but it's also the people that are going to help understand the data. I mean, one of the most important things when you work with any outside firm, whether it's Software Design Solutions or somebody else, is to realize that they're not experts in your business. Almost all the time. Very seldom are you going to go find someone, that maybe you run a set of industrial facilities that stamp out metal parts. Anybody who knows that stuff is probably not a consultant. They're probably your competitor. And so the most important thing to do is to bring someone in who understands collecting information and collecting data and sensing, of course, because sensing is important, but get them together with your own internal data domain experts, we call them. So this is, not necessarily someone in a lab with a lab coat and a PhD. This might be the foreman on the line that has been with that machinery for 15 years. And they understand that machinery. That's who we would refer to as a domain expert. And so if you're talking about machine downtime, it's very likely to be someone who works on that machine and understands that machine. And so by pairing that person who understands the domain with a classical data scientist from SDS or a classical hardware engineer from SDS, so that they can understand the combination of what's possible to collect in terms of hardware for sensors and things like that, and what's a reasonable analytics to do on that data. They compare with the domain expert to say, is this reasonable? Is that reasonable? What do you do today? What do you wish you had? We work with customers who have terrific data and domain experts. We have a customer that they can dig out old notebooks full of data from decades ago to say, here's these parts, here's how many times they were serviced, here's what the test results were from QA. And, to come in and say to a customer like that, no, we know better. We know better how to do that. Ignore that information. We're going to provide you this whiz-bang, cloud-based fog compute system, and you can ignore everything you currently know. That's just silly. Mm-hmm. Mm-hmm.
Recipe for disaster. So the big thing around data that always intrigues me with Internet of Things is I think there's I don't know if it would be a misconception, but I think it's a fear that with sensor data or data in IoT, if you will, that there's just so much of it. Like, how do you sift through all that noise and find the signal? So with sensor data, how do you communicate that with your customers of, look, you're going to be inundated with data, whether it's from the sensors, the machines, the systems, the processes, the customers. How do you make sense of all that and kind of filter it down into either dashboards, reports, or results that provide value for the company?
Yeah, that's a very good point, Andrew. I fell into the trap early on in IoT of following along with what people were saying, which was collect it all and sort it out later. The cloud's a big place. Just store it all. You'll find use for it later, and you'll throw away what you didn't need.
Right.
And that's not really correct. That's not really the way to approach it, and it scares people, especially after they get a couple of cloud bills. I think that the most important thing is to go back to the processes they're trying to improve and the systems they're trying to look at and say, what data interacts with those systems. If I want to measure machine downtime, I probably care about vibration and temperature and those kinds of things on the machine. I probably don't care as much about, trying to think some things maybe I don't care about. Maybe I don't care about the humidity or the rate at which the machine next to it is working. I might find out that I care about which operator is which on the machine. Maybe that there's some operators that are a little kinder to this machine than others, and so that's where involving that domain expert is really key, because they can help you narrow down from the potentially hundreds of things you could collect and really inundate and confuse the process to maybe the 4 or 5. And that's why we really have very early on switched our model to, okay, we're only going to collect a few things and go from there. Kind of this very small low-hanging fruit. So let's just put a temperature sensor on this bearing, see what that does. Is that inexpensive to do? Yes. Off-the-shelf temperature sensor, off-the-shelf, radio module, sending that data to our asset management system to collect it and view it, and what analytics do you use? Maybe you just use Excel. Maybe that's what you're happy with for now. Let's see what that gets us. Instead of really making the process into this large, we need this great big analytics system and this dashboard and these wizards. We'll get there, but we'll get there incrementally, and what we'll end up with is something that we did thoughtfully rather than kind of shoved it in the back door.
Sure. So with some of your customers, and specifically I think some of these domain experts or folks that are on the shop floor and are responsible for manning and tending and the maintenance of these machines in some cases, what sense do you get from them when you're engaging with them? Do you feel like this is just voodoo to them, of this will never be as accurate as their gut feel for this machine or this system? Or do you feel like they embrace it as something that provides value and yet another thing that enables them to kind of coexist in this world between data and sensors and the machine, if you will?
I think that's a very important thing to address early on in the conversation. We talked about stakeholders, and the reason why we feel like finding those domain experts and getting them in the room early is an important part of this, because we need their buy-in, because we need their help. And so if it was just, SDS meeting with the C-levels, signing a purchase order and saying, go off and do this cool thing, and then we show up with it a few months later and try and bolt it onto the machine while the guy who is really the domain expert stands back and say, that's never going to work. He had no part in it. He had no part in it. He has no ownership of it. And I think that's important. This person is just as important of a stakeholder. Similarly, IT. There's this whole IT versus OT adversarial relationship that doesn't have to be adversarial. Mm-hmm. If we have the IT representative in the room, she may be able to upfront say, well, you know what you're saying will work, but we have to do it this way. But again, if we show up 3 months later, she might just say, that's not going on our network. and that could scuttle the whole project.
Yeah, I think or at least I agree 100% that inclusion of those stakeholders early and often provides nothing but value. Obviously, there's road bumps and hurdles and things that often have to be overcome, but I think it's definitely important to make sure that everybody's on the same page and marching in the same direction.
Sure, that's right.
So a couple more questions before we wrap up. So kind of tying things back to data, where do you see the biggest challenges and or the biggest opportunities as it relates to data in this new world of IoT?
I mean, I think that there's been a lot of discussion about machine learning, and I think that machine learning has a good deal of opportunity, but I think it has to be treated as a tool that the combination of the domain expert and the data scientist uses. I think that machine learning is often kind of treated like a panacea, and folks say, well, we want machine learning on that, and we kind of have to talk them back off the ledge and say, well, what you're describing isn't a machine learning problem, it's a heuristics problem. What you're trying to achieve here can be achieved with a simple heuristic, and here's the heuristic. The temperature goes above this set point, raise this alarm. Now, there might be plenty of machine learning opportunities in the broader scheme of that temperature versus this vibration versus whether it was the Monday after Super Bowl and all of those things. Believe me, lots of machine failures probably happen the Monday after Super Bowl. And so, especially on the losing team. Right? I think that there's a lot of opportunity there. In terms of collecting data, I think the opportunity to have the new hardware that's available in low power sensors has allowed us to put sensors in harsh locations and remote locations in places where we couldn't have before and make them battery operated. And I think that is allowing us to place sensors on machinery where we wouldn't have been able to 5 years ago.
Mm-hmm. So that kind of leads into the final question of what's next. What do you see on the horizon as it relates to IoT, these types of projects? And you kind of alluded to it a little bit there about the costs going down and the ability to deploy these in previously undeployable locations. But any other tidbits of information that if you had a crystal ball where you see the next 5 years?
I really think the entry of these low-cost cellular connectivity technologies, and I'm not talking 5G. 5G is kind of the antithesis of what I want. I'm actually a little upset that 5G and what I care about, which is NB-IoT and LTE Cat-M1, came out at the same time, or roughly, because 5G gets all the press and all the push, and folks ask us, do we care about 5G and these sensors? I said, I don't know. Are you going to stream Netflix onto the sensor? I don't need 5G on this sensor. What I need is an NB-IoT cellular connectivity that is power friendly. It will cost me $1 a month instead of $40 a month for a cell phone kind of connectivity. And it will let me place this out in the boonies somewhere, because something like Cat-M1 runs on the current LTE network. And so that is going to allow the kinds of things where you talk about agricultural sensors out in the middle of fields, maybe with a little bit of solar power, but maybe only a battery. And those kinds of things would just be unheard of 5 years ago, and they're just now coming into the forefront. As we go further and we start talking about these sensors providing this data and maybe mesh networks being able to hop that data back to where they can get to finally a connection to the internet, I think that's going to allow for new types of data to get collected and then analyzed.
Perfect. Well, Ed, thanks so much for joining us today. I'm always fascinated to hear other people's points of view around these topics. And to our listeners, hopefully there's some good nuggets and takeaways of this conversation today.
Thank you for having me on, Andrew.
For those of you listening, if you'd like to learn more about Ed and software design solutions, I'd encourage you to visit https://softwaredesignsolutions.com. And if you'd like to connect with Ed, we'll be sure to provide relevant links to the online profiles in the show notes. If you enjoyed this episode, please take a moment to rate the episode and subscribe to Data in Depth, available on iTunes, Google, Spotify, Stitcher, and pretty much anywhere else you might listen to your podcasts. Thanks again for joining us today.
Data in Depth is produced by Mountain Point, a digital transformation consulting firm focusing on the manufacturing sector. You can find show notes, additional episodes, and more by visiting dataindepth.com. Thanks for listening, and be sure to subscribe wherever you get your podcasts.